In the last problem, the change in charge over time was described using a graph. But this time, it's a bit different. We are working with an equation. This equation lets us calculate the total charge entering the terminal at any moment by just plugging the value of time. For example, if we plug in 0.5 seconds, the charge comes out to be 0. Now you might be thinking, well, if the charge is 0, the current must also be 0, right? Since we know that I equals to Q by T. But that's not actually the case. Let's take a step back and look at the graph of this equation. As you can see, it's not a straight line like before. Instead, it's a smooth curve. This tells us that, unlike the previous problem where we had a constant current, here the current is changing all the time. Now that formula for current, I equals to Q by T, only works when charge flows at a constant rate. More precisely, we use I equals to del Q by del T, which is Q2 minus Q1 over T2 minus T1. But if we are starting with zero charge, then we get that particular equation. Since here we have a changing current, therefore I equals to Q by T is not going to give the correct result. As we discussed in the previous video, the slope of a straight line is unique. And for the Q versus T graph, it is equal to the current. On the other hand, the slope of a curve varies point to point and is defined by the slope of the tangent line drawn at that point. To put it in simpler terms, we can approximate any curve by breaking it down into small line segments. The slope of the curve at any point is equal to the slope of the line segment at that point. This is rather a geometric approach and great for visualization purposes and helps to comprehend the concept easily. But if we know the equation of the curve, then we can take an algebraic approach instead. By taking the derivative of that equation, will gives us its slope as a function of the independent variable. For the curve in this problem, the derivative of the equation is dq by dt is equals to 20 pi t times cos of 4 pi t plus 5 times sine of 4 pi t. I won't go into the details of how to take derivatives here, that's something you will learn in calculus. But remember, dq by dt is just the rate of change of charge with respect to time, which we defined as the current. So this is actually the equation for current. Now if we plug in the time value, we can calculate the current at any moment. For example, at t equals to 0.5 seconds, the current is about 31.42 milliampere. So even though the charge is 0 at 0.5 seconds, the current isn't. The key takeaway here is that the current deals with the change in charge, not the actual amount of charge itself. Finally, we can plot this equation on a graph to visualize how the current changes over time. And that's it. If you need any help or just want to support the channel, please become a Patreon member, where you will also find solutions to selective exercise problems like this one. See you there.